Logarithmic properties, algebra 2 trigonometry regions. So a couple of log properties, and I'll explain briefly where they come from, but basically you need to know how to work with these properties and kind of convert back and forth between the two. One of the key notes in the intro video, the previous video on logarithms was, and I think it was believed that the first thing that I said was that a logarithm is an exponent. And it's important to know that because if you remember about the properties of an exponent, that if you were to say multiply a common base term, like x squared times x to the fifth, what happened was you ended up with x to the seventh. You added the exponents because of a multiplication relationship, and that's kind of what we see here, that these adding two separate logarithms comes from a multiplication of them. And for division, if we divide, we were to subtract our exponents, and it's the same principle here. And then one third property is that an exponent raised by an exponent is like multiplication again, and we see that like if we had x squared to the fifth, it ends up as x to the 10th. An exponent raised by an exponent is multiplied. So log a is an exponent. Being raised by an exponent is like multiplying that number times that exponent. So that's a key important property right there. And then this right here, log 10 equals 1. In the previous video, I talked about the common log. And the common log was a log that is a log of base 10 is the same thing as a log with no base written. So log of 10, remember there's no base here, we can assume it's a 10. So that's like log base 10 of 10 equals 1. And that should make sense simply because if you were to convert this into exponential form, that's like saying 10 raised to the first is of course 10. So if you ever see log 10, we're going to simply turn it into a 1. Now we need to go back and forth with these. I call this expanding when we go this way, like when I take these terms and expand them into multiple logs. And then going the other way, I call it contracting. And so sometimes we start like this and we want to write it as a single logarithm that way. These properties, after a little bit of practice, become almost second nature. That, if we're expanding a logarithm, a multiplication can be expanded to a sum of logs. A division can be expanded to a difference of logs. An exponent by an exponent, the exponent can be written as a coefficient of the log. And then going the other way, contracting that, if I have a sum of logs, I can write it as a single log product, or a subtraction of logs or a difference of logs, I could write it as a single log division. And if I see a coefficient in front of a log, well, I really know it comes from an exponent of that log. So let's just do a couple of practice problems playing with these properties. All right, so the expression log 4m squared is equivalent to what? So you see how this is a single log expression, and then take a look at my answers. They're multiple log expressions. So what I'm doing is I'm expanding this logarithm. So there's a couple of things happening here. If we see what's this is, 4m squared. That's 4 times m, and m is being squared. Now, again, notice that only m is being squared. If both of them were squared, we would need parentheses around the 4, but we don't. So two things are happening here, two properties. I see a multiplication between 4 and m, and I see an exponent on the m. So first, this multiplication, log 4 times m squared, our multiplication can be written as a sum of two logs. So right there, I'm going to make that log 4 plus log m squared. So my single log product can be written as a double log sum. So I split up 4 times m squared to 4 plus m squared, and they each get their own log. Then the second thing that's happening is this exponent here. My log has an exponent. And the rule for when your log has an exponent is that that exponent can be moved to the front of the log as a coefficient. And so this exponent I can write as a coefficient of that log. And so that would be log 4 plus 2 log m. And that is right here. A is what some people might think. So our exponents go to the front. But again, that would be if it were like 4m and they were both being squared, then the 2 would go to the front of both of them. But that's not the case. The 2 here is only applied to that m. That's why it's only going in front of the log that has the m. Another expanding one here. All right, now what I see on top here is a cubed root of a. Now, one thing that you see a lot with logarithms is from that exponent chapter, that remember how something like, say, the square root of x is the same thing as x to the 1/2? Well, you're going to see a lot of that, like when I have radicals, or the cubed root of x is the same as x to the 1/3. Because remember, this is an exponent concept, logarithms. So first thing you want to do is if you see any radicals like square root or cubed root, convert that into an exponent. So first, let me just write this as, so no log properties yet, just deal with this radical. And so let me write that as a to the 1/3 divided by b. And that's the same thing. Cubed root of a is a to the 1/3. Again, only being applied to the a, not to both a and b, all right, because the b is not under this radical in here. And so now I'm going to deal with this. All right, the division of logarithms can be expressed as a difference of logarithms, and that's what we see in our second property here. Log a divided by b, or a fraction, which is division, can be split up as a difference of the logs, where it's your numerator minus the log of the denominator. And so that's what we're going to do first here, is that would be log a to the 1/3 minus log b. So I expand my division into a difference of two logs. And then once more, I see I have an exponent, which I'm going to place in the front to get 1/3 log a minus log b. And that would be here. Okay, B, a lot of people will get the wrong answer B because they know the division turns to a subtraction, but they forget that they have to each get their own logarithm. When you're expanding something like this, each variable gets its own logarithm. So if you have a single log with an x, a y, and a z, you're going to end up with 3 logs expanded. One more example, but this time the other way. So I see multiple logs, and I want to contract it to a single log. So this time I'm going this way with it. All right, so first of all, this whole log base of x equals, and they want to know what x equals. It's still this property stuff. Just in the end, I'm going to drop the logs and see what's left. But so let me just focus on this part over here right now. Okay, so first thing, just looking at this one. Now, these little b's here on each log just stands for base, and it's showing that they all have a common base. Sometimes problems write it like this one doesn't have it, this one doesn't have it. Sometimes problems write those little b's, often they don't. If you see the little b's, you could pretty much just not worry about it. It's just basically like saying they're all the same. That's okay. So 3 log p. So first of all, I see a 3 in front of the logarithm. So where does that come from? Well, what we were doing in the previous 2 examples is when I had exponents, I moved them to the front. Going the other way, numbers in the front become exponents. So this 3 log p can be written as log of p to the 3rd. So that goes back to being an exponent. This minus here tells me it comes from division, right? We saw a division, we made it a difference. So I'm going the other way. When I see that minus sign, I make the division sign. And then I know that both of these variables, the t and the r, are going to be down here because they're in parentheses after the minus. And so that's what tells me they're kind of grouped together. So what's happening down here? Well, for log t, I have 2 log t. Well, that's going to become an exponent of the t. So that's t squared. And this 1/2 will become an exponent of r. And then what's happening between them is a plus, but going backwards, that means product, right? When we saw the this 4 times m, we made log 4 plus 2 log m. So the plus going the other way means as a single log, it's a product. So So this plus between them means I'm multiplying t and r with their exponents. So this 2 goes to t and the half goes to r. So times r to the half. And then there's a good chance that they're going to express this half as a square root. So that would be log p to the third over t squared and the square root of r. And so log base of x equals this. So then they're saying, all right, well, what does x equal? Basically, they're saying, all right, let's just drop our logs here. And this is what I'm looking for. So p cubed over t squared square root of r. And if you look at some of these wrong answers, this one is ignoring the division altogether. This one is thinking that t squared and r are being square rooted, but you can clearly see that this half is only for the r, not for the t and the r. This one is thinking that the t should go on the top, but that doesn't make sense because it's after the minus the t is. So that's how we do it, just playing with these properties, and we'll explore some more tomorrow.